Good morning, friends. Our today's topic is drying. This is also one of the most important mass transfer operation subject, and it also belongs to unit operations that to be carried out in chemical industry. Basically, the drying is the last operation that to be carried out in chemical industry, because why? After drying, the product value may be increased. Drying is a very essential part of chemical industry because for transporting the material from one place to another, dry solids can be handled easily as compared to wet solids. Again, dry solids are specifically sell with higher cost than the wet solid. So to increase the sellability of your product, drying is very important. Sometimes the moisture which is present into the final product may give some of the different properties to that particular solid. So to avoid that toxic or corrosive properties, we need to dry the substance. So the drying is very important unit operation in chemical industry. Now, before proceeding further, first we must know why the drying is very important. Drying is specifically important in chemical industry to increase the product quality as well as to increase the product sale value. Now, in this particular lecture, we'll see the rate of drying or the drying curves. For that, first we must know the moisture content of your solid. Now, let us consider that some sample is given to you, wet solid is given to you. Now, the wet solid which contain the moisture, but that particular moisture is of different types. Now let us see that if we focus on the equilibrium curve of that particular sample, or if we focus on the equilibrium curve of drying for any particular sample, first we have to focus on this diagram. This diagram is nothing but the relative humidity versus the moisture content of solid. Moisture content means what? It is the per kg of moisture present in kg of dry solid. Now let us see that any particular solid has different moistures. The first thing is that unbound moisture, then again bound moisture, again the free moisture, and the equilibrium moisture. Now what do you mean by equilibrium moisture? Actually, in case of drying, what we have been doing is that one particular solid is to be making contact with some of the air or evaporating media. Now here, in this particular solid, some of the moisture content is there, some of the vapors are there. This vapor have some vapor pressure. This moisture have some vapor pressure, and this air should have sufficient temperature, sufficient humidity, and sufficient partial pressure of that particular air. When the partial pressure of air is equal to the vapor pressure of the moisture, then we can say that the equilibrium exists between this air and this sample. That means the vapor pressure of moisture is equal to the partial pressure of air. Then the equilibrium is set. But after the equilibrium, there is no further drying is possible. Suppose we have to again dry the substance, then we have to change the condition of this air. That means we have to change the temperature, lower the temperature, we have to change the humidity, and we have to change the partial pressure. Then and then only we can dry the substance. Now, the substance which has some unbound moisture, bound moisture, free moisture, and equilibrium moisture. We can dry the substance up to the equilibrium moisture. That means at the end of your drying, the equilibrium moisture must be present in your substance. Below that, we cannot dry the substance. Now this is the drying curve, rate of drying curve. If we plot the rate of drying versus the time, the drying curve follow this path. That means A, B, C, D, and finally E. The drying must be followed the path A, B, C, D, E. This pattern is as similar as that of the different sample. That means suppose we have n number of drying samples. In that case, the same type of patterns frequently observed. And if we plot the tangent to every surface, every point over the drying curve, then we found this type of curve. This is also rate of drying curve. By using this curve, we can find out the time required for any particular drying. This curve has some sections. This first section is the warm-up section. The second section is the constant rate drying. And the third section is nothing but the falling rate drying. This is the rate of drying. It can also be given by this formula. Rate of drying is proportional to the surface area of sample, then moisture, driving force, moisture content, area required for drying, and this is the time required for the drying. Now once we plot this rate versus the moisture content, the graph follow this pattern. Initially this A to B or A dash to B, this is the warm-up period. That means suppose we are taking the sample for drying, initial heat supplied for the drying is giving to the warm-up period. That means the temperature of that particular sample maybe decreases or sometimes it may be increases up to the point B. From B to C, a thin film of vapors is available over the surface, and that moisture may get removed during this period. During the period B to C, the rate of drying is very constant. But at point C, the rate try to decreases. That means after the section B to C, the rate is constant rate, and from C to D, it may be the falling rate period. We can say that at point C, the moisture present is also known as XC or the critical moisture content. Again, we have one definition, critical moisture content, the moisture content in which the constant rate period ends and falling rate period starts, known as the critical moisture content. From C to D, the drying rate decreases. The drying rate decreases. Over the surface, whatever the free moisture is available, that can be dry by using this constant rate period. But now from C to D, now some surface cracks may be observed over the surface. And up to the point D, that surface cracks may be observed. That means from that particular cracks, your drying will be there. From D to E, some of the sprockets may be available inside the surface, and the moisture which is accumulated in particular blocks or in particular sprockets, that can be evaporated at certain extent. That means from D to this E. D to E, the last drying will be observed, and at point E, your drying will be stopped. At point E, the equilibrium is exist between the drying medium and your sample. That means we can say that the vapor pressure of the moisture present inside the sample is equal to the partial pressure of your air stream or the air medium, and that stage is arrived here, and that particular moisture content is known as X star or the equilibrium moisture content. By using these two curves, we can easily say that for any particular sample, how much drying time is required, that can be easily calculated by using these curves. The time required for the constant rate period is given here. The rate is given here. And again, the time required for this falling rate period can be calculated by using these curves. Once we know the time required for constant rate, once we know the time required for the falling rate, by combining both time, we can easily calculate the time required for the drying of particular substance. In next lecture, we'll see some of the problem based on this theory. Thank you.